In this video, we're going to talk in general about functions of several variables. And first thing that we should do is just define what we mean by a function of several variables. So let's say that in a function of several variables, the input is two or more variables. And I would say in most situations, the input is going to be exactly two variables, just because those are the situations that are the easiest to graph and to visualize and that are most in tune with our physical understanding of the world. But in general, we could see more than two variables. So if we were to write down some typical examples of functions of several variables, we could write f of x, y. So that's just indicating that the input is two different variables. And then we could give the formula for what f looks like. So we could say f of x, y is x squared plus y squared. An equivalent way to write this, we might sometimes just write f instead of specifying how many input variables we've got. We would just call our function f for short, and we would say f equals x squared plus y squared. A third way to do this, sometimes we prefer to call the function f, just give it a new variable name, like z equals x squared plus y squared, and that's especially useful in a context where we're going to be graphing the function. And then let's think about how to evaluate the function. So let's say that we wanted to plug in an x and a y value. So we could say f of 2, 1, meaning we're evaluating this function at x equal 2, y equal 1. Plug into the formula, we'd have 2 squared plus 1 squared. And so instead of writing all that, I'm just going to say that's equal to whatever that works out to. So that's equal to 5. Now, if we were using the z notation and saying z equal x squared plus y squared, a more natural way to write this is actually just in terms of an ordered triple of points. So now we'd be thinking geometrically about a certain point that lies on the surface that we're about to sketch. So you could say when x equal 2 and y equal 1, the value of z is 5. In other words, we're thinking about this ordered triple 2, 1, 5 as being a point that belongs on the graph of this function. So let's start to talk about graphing. So when we want to graph functions of several variables, we need at least 3 axes. Typically, we'll just be using 3 axes because usually our functions will just involve 2 input variables. So we're talking about the 2 input variables and then the single output variable z. So we imagine that the positive x-axis is coming out of the screen straight at us. The x-axis is perpendicular to both the y and the z-axes, but we just draw it slanted because of our perspective. And then the positive y-axis going to the right and positive z-axis going up. So let's think about how we would graph a point like this point right here, the 2, 1, 5. So we need to go 2 units out along the x-axis, 1 unit along the y-axis. And you can imagine just forming a little parallelogram here, parallel to the x and the y-axes. And you can say, that point right there corresponds to, sorry, I keep hitting the input button here. So this point right here is the point 2, 1, 0. So 2 units out along the x-axis, 1 unit along the y-axis, and we've gone 0 distance vertically. And if we then from there wanted to go 5 units vertically, we could look at the z-axis and we could just figure out, even measure with our fingers how far we think that distance of 5 units vertically is, just eyeball that. And then from the point 2, 1, 0, move that distance, whatever we judge that to be. So 5 units vertically might look like about that. And so that gives us the point 2, 1, 5 right there. So that's how we think about drawing points in 3D. So if we were to think about all the different x and y values that could be input here and figure out the z value that goes along with each of those pairs of x and y, figure out all those points, and then plot all those points. Here's what the picture would look like. So we would end up with a bowl shape like this. It's actually an infinite surface, so it continues up like this, but usually we just draw it to be finite so that we can understand the shape of it. So that is the graph of z equal x squared plus y squared. Just a hollow bowl. We're just talking about the outside shell of that bowl. That's representing the set of points x, y, and z that satisfy that equation z equal x squared plus y squared. So over the next few videos, we'll talk in more detail about how we actually make the graph of this surface that is representing this multivariable function. Thanks for watching.